We love ninja math. At least I do. Alright, first thing we got to talk about, rational, means a fraction. So we're dealing with things that are written as fractions. So these are going to be big fractions, which means that sometimes our domain is going to be restricted. Why would your domain of a fraction be restricted? What can never be on the bottom of a fraction? 0. So that's what we're going to look at first off in this, is what would make our domains be restricted? What would make the bottom be a 0? So if I had a function that said f of x is equal to x plus 6 over x squared minus x minus 6. Okay, all we're going to do on this one before we get into the fun stuff, it says for the rational function, find all numbers that are not in the domain. Okay, so what cannot be in the domain would be what would make the bottom a 0. Okay, so how do I find out what would make the bottom 0? Several ways you can do it. You could just set it equal to 0 and solve. See what makes it be 0. Okay, and all before Thanksgiving, that's what we had been doing with that. We had been factoring that bottom. So I can take that, factor it. A times c, the factors of -6 that add a -1 would be -3 and 2, right? So this denominator would factor as x minus 3 times x plus 2. Now if I set those equal to 0, that means if x was 3, I would get a 0 on the bottom. Or if x was -2, I would get a 0 on the bottom. So I cannot have the numbers 3 and -2 in my domain. Oh, a fancy way to write that, I could say my domain is not equal to those two numbers. Okay, there's one way we could write our domain. I could say my domain is all real numbers except 3 and -2. That way it would take longer to write. I like the not equal sign up there a little bit better. Okay, but how did we get that? We just factored it, set it equal to 0 and solved. Pretty easy. Not too bad yet. Alright, even easier one. This one says f of x is 3 plus 2x over 5. The directions are the same. What cannot be in our domain, or what is your domain? So dealing with the domain. The only time with fractions that you've got a restriction is when you got a 0 on bottom. So how can that 5 ever be a 0? And I'm not plugging any number in. I mean, if I plug a number in for my variable, it's only on top. The 5's not going to change, is it? Good. So my domain on this would be all real numbers, because it's never going to be a 0 on the bottom. Another way to say it would be what we've done before, negative infinity to infinity. So if you got just a number on bottom with no variable, you don't got to mess with it. Your domain could be any number you wanted it to be.
So no matter what's on the top.
It's only the bottom.
One number down there.
Yep. Alright, well, let's do some multiplying and dividing. This is the fun stuff. Alright, I got y squared plus 2y minus 3 divided by y squared minus 3y plus 2. Okay, directions on this just say to simplify. Write in lowest terms. Well, we can't, and that's an okay thing to think about. When we've got division with same base, you subtract the exponents, that's true, but I can't do that here, because I can't like take a piece of the trinomial away. It's got to be the whole piece or nothing. Remember me saying you can't pick apart stuff last year? It's got to be all or nothing on that. So what I'm going to try to do, I mean, this is a division line.
Couldn't subtract my turn.
because it's going to be the whole thing or nothing. This is a division line, so I could do long division, but I ain't gonna. I'm not going to do long division on any of this kind of stuff. What I'm going to look at is like we just did on the domain stuff. I'm going to see if I can factor that, because then if I can get the same binomial on top and the same binomial on bottom, then I can mark the whole things out. That's when we did our ninja math that y'all were talking about last time. So on the top, will that numerator factor any? Okay, what are the factors of -3 that add to 2? So I would have y minus 3 times y plus 1. That's the same thing as this, right?
Right.
Good. What would the denominator factor is? What factor? Good, they both have to be negative. Y minus 2 and y minus 1. Now, since I've got binomials on top and bottom, if I can mark out a whole binomial, this is what I get to do. So I'm looking for same thing on top and same thing on bottom. And we don't have anything. Okay. But slow down and look at your numerator again. We didn't factor. Y'all might have told me right. I wrote it down wrong. My numerator's not factored right. Yeah, to make this a positive 2, my 3 would have to be positive, and my 1 would have to be negative. I hope that's what y'all told me, and I just wrote it. Okay, good. All right, so now I see those y minus 1s, and then we say, what time is it? Ninja time. So all we've got left is y plus 3 over y minus 2. That's it.
Like math ninja, you know that? Like fruit ninja?
That'd be fun. Your negativity is dampening.
Let's do another
my
one.
spirit.
The rain is dampening my spirit.
Is dampening even a word, or did we just make that
I
up?
don't think it's
School's better than mine now.
Awesome. You got 2 weeks.
2 weeks, you know what?
So what?
There's no one to
Did it? No, it's 3, but that last week will be like semester test stuff. I don't know if you're exempt or not. I don't know.
No, there's a see here, Coach Right. It says I'm just like,
Actually, all I've got is okay, this one could be a trick. It says y plus 2 over y squared plus 4. The directions say to write in simplest form. Remember, you can't pick apart binomials or trinomials. You got to be able to mark out the whole thing or nothing at all. Okay, so what we're looking for, since the top, can I do anything to the numerator? Does it break down in any way? Y plus 2 is what it is, so that's going to stay y plus 2. Now the denominator, can that break down?
Yes.
Yeah.
No. There's no such thing as sum of squares. We talked about that before the break. If that was a minus sign, this would be y plus 2, y minus 2, right? But because that's a plus sign, it cannot break down. If we tried to write that as y plus 2, y plus 2, when you foiled it, you would have a middle term there. And this one doesn't have a middle term. Remember that? Okay, so that won't break down at all. The plus sign will not let that break down. So I can't factor it any. That's already in simplest form. So you could write simplest form, anything along those lines.
Can't be so serious. You're a serious person.
Okay, let's do another kind. This one I've got 1 plus p cubed over 1 plus p. Alright, this will be a fun one because you won't remember this.
That's so fun.
I didn't remember the some.
That one?
Yes, those are 1. Alright, the denominator. I always like to look at the simplest stuff first. The denominator, 1 plus p. Will 1 plus p break down? No. It's just a 1 and a p. That's as far as it'll go. What's special about the numerator? How will the numerator break down? Because it will.
It'll go into
1 plus
1
b,
plus
1
b, 1
plus
plus
b,
b.
1 plus b.
No. It is a sum of cubes. Okay, remember your sum of cubes. What's the cube root of 1? 1. What's the cube root of p cubed? P. Sum of cubes starts off with our a plus our b times a squared, 1 squared,
Plus
minus a times b, so 1 times p, plus b squared, so p squared. Remember sum and difference of cubes.
Ninja.
Now you got binomials on top and bottom. What time is it? Ninja time. So all you got left is 1 minus p plus p squared.
I thought it had to be a minus sign. The 1 plus b.
That was because it was
You thought which one needed to be a minus sign?
You said something about it had to be a minus sign or we couldn't do it last properly.
That was, and what Angie was saying was correct. That was because it was perfect squares.
Okay, well,
Cubes, it can be a plus or minus either one. Good thinking. Alright, gotta do some, we're fixing to get to some really fun stuff, but before we do, we gotta do some work with some signs. So this one says r squared minus 16 over 4 minus r.
Hey, you can do this.
Okay, on the top, good. Top one, shh. Top one will be difference of squares, right? So I've got r plus 4, r minus 4, good job. But, looking on the bottom, that's 4 minus r, so I don't see anything that I can ninja out yet. Okay, what? I've never had to yell over the rain before. What I need to notice is that r is a positive. That's, I said that backwards. That 4 is a positive and that r is a negative. So if I flipped them, that would be negative r plus 4, right? I don't have any of that up here. But what if I took a negative out? Negative r divided by negative 1 is a positive r. 4 divided by negative 1 is a negative 4. Hey, ninja time. Okay, so you could write this answer several ways now. You could write it as r plus 4 over negative 1, because that's what we ended up with. But dividing, unless you divide it by negative 1, doesn't that just change all the signs? So you could also write it as negative r minus 4. That'd probably be how I would write it, but they're both correct. Woo-hoo! Did you have a good Thanksgiving?
I guess so. I don't woke up because they're loud.
So my dad made me
Because you know the last thing like before they
like most of the day.
like everything was bad. I was starting to I was gonna finish all mine last night. I was gonna go through but I didn't. I spent the whole night playing and working on my essay.
Okay, this is what we've been leading up to, doing some multiplication here. The one on the left, I got c squared plus 2c over c squared minus 4. That's a minus, so we make that minus bigger. Times c squared minus 4c plus 4 over c squared minus c. Alright, let me tell you what your options are. You could, because this is multiplication of fractions, you could multiply straight across the top, straight across the bottom, and then try to reduce. You could. It's just my opinion, and the way I'm going to go with you is I'm going to reduce first, and that's ninja math, and then I'll put together what's left over. It's easier to do that, in my opinion. Okay, so in order to do ninja math, I got to be able to mark out whole pieces. I don't see any whole pieces I can mark out yet. So step one of this is always going to be to factor everything completely. So let's just go through the pieces. Top left, that will factor. What's the top left? How does it factor? It's got a C in common, so I'm going to take a C out of both of them. That would leave me with C plus 2. Okay, can I do anything else with the top left? No. Alright, how does the bottom left factor? And it will. Difference of squares is good about it. That's C plus 2. C minus 2. Okay, I'm to the top right. Top right will also factor. What factors of 4 add to negative 4? Negative 2 and negative 2, so that would be C minus 2 and C minus 2. Okay, and to the bottom right. Does it factor? Yes. What does it factor as? It's got a C GCF, so you take that out. Leaves you with C minus 1. Now, when you get your ninja sword out and start chopping here, it's got to be top and bottom. It can be top left, bottom right. It can be diagonal, but it's got to be top and bottom. Okay? So I got, okay, C plus 2. C minus 2. C's.
C minus 2 over C minus 1.
That's all you got left. C minus 2 over C minus 1. Every year I'll have people try to mark the C's out, but remember you can't pick that apart. It's got to be all of the piece or nothing. That's it. Yep.
That's what she's saying.
Alright, so I'm going to let you try one. Yep, multiplication. I got m squared minus 16 m plus 2 times 1 over m plus 4. Alright, see what you can do with that one. Go.
Maybe the power will go out again, so I'll get
I don't know. There are supposed to be high winds today. So
Yeah.
Are you giving
Oh,
us
I
those?
hate that power line. What? That's
I'm worried about my car because you're so lazy.
Oh no. Mine's pretty light. He's already leaving.
did she make some ninja noises?
That's awesome. The person last year who was most into ninja math was like Jacob Jackson and Tom Fowler and stuff. They were just really into it.
That's funny.
I mean, I'm the one with that.
We did. Check it out his all year long. Because this is the my mom never bought me. My mom never bought me the books.
If it's time for one, you really have to do it.
But now I like that I can look back on these yearbooks and see what you guys on board.
Okay, there was only one piece of that that could factor. Top left. How did the top left factor? Yeah,
M plus 4, M minus 4.
same thing. Okay, so there's my top left. I'm just rewriting everything. You don't have to rewrite it all, but I am. So I only have one piece that will ninja. M plus 4. Okay, so on the top, what I've got is a 1 times an M minus 4. And on the bottom, an M plus 2. Now, I wrote it like that on purpose because the girls over here were talking about that. What do you get when you distribute a 1 to that thing?
Same.
m minus 4. So if you don't put the 1, that's fine. It would actually be more normal if you don't.
More normal.
I strive to be normal. Doesn't always work.
Normal. What if people said that?
Be more normal. Alright, let's look at division. I got 5p plus 2 over 6 divided by 15p plus 6 over 5. Alright, before we get started, we got to remember what we do when we divide fractions all the way back to about the 4th grade.
What? 4th grade?
You know, like you've slept since then.
Not really.
What do you do?
Keep change flip.
Good. I like that. You had a good 4th grade teacher. I've never heard that before. I like it.
Flip. Hate betting because we went to betting.
Keep the first one like it is. Change it to a multiply. Flip it. Very good. That was good. I've never heard that. Keep the first one like it is. Change it to a multiply. Flip. Keep, change, flip. I just always say multiply the reciprocal. But I like keep, change, flip. Alright. So 5p plus 2 over 6. Change it to a multiply. Flip to this one. Get the reciprocal. 5 over 15p plus 6. So a division problem is a multiplication. We just made it a multiplication. But I don't have anything I can ninja. Is there any of that can factor?
No. Yeah.
Good, better. That 15p plus 6 has a GCF of 3, doesn't it? So this is the same as 3 times 5p plus 2, right? So now, my 5p plus 2, is there anything else? Remember, I've already replaced that, so don't get confused with that. So on the top, I've got a 5. And on the bottom, I've got a 6 times a 3. So it's just 5/18. It's crazy that we had p's in there and we ended up with a normal number.
You know, math is a lot easier for the algebra.
You know,
I don't understand. Sometimes we don't even have numbers. It's just straight letters.
I don't know.
I was helping my little sister with multiplication in middle school, and like I'm sitting there, I'm kind of thinking of the whole 9th street because they're doing like 9 right now. And she's like, I don't like this because I was doing like this so she could look at it for the teacher. And she's like, I don't like how I have to do like this with her. So he's like, face it towards you.
Yeah, and they were struggling.
Silly rabbit.
They had to do multiplication.
Alright, so look at another one. X squared plus 2x over 5 plus x divided by 4 minus x squared over 3x minus 6. Okay, now since you remembered your multiplying the reciprocal or your keep, change, flip, you've got options on, do you want to rewrite it as multiply first or do you want to factor it first? It does not make one bit of difference. You can do whichever one you want first. I think I normally write it as multiply first, but it doesn't matter. So I'm going to go ahead and rewrite it as a multiply real quick. X squared plus 2x over 5 plus x times, and then I flip this one. 3x minus 6 over 4 minus x squared. Okay. Now, I only see one of those that will not factor. Good, that 5 plus x is already prime, so everything else is going to do something. What's the top left going to do? It's got an x out, good, so that would leave me with x plus 2. We said bottom left won't do anything. Okay, what about 3 minus x? What will it do? Okay, what about the bottom left? Okay, good, good. The first thing I see on that, let me tell you what Valentina's talking about here. The first thing I see on that is it's a difference of squares like it is. 2 plus x, 2 minus x. But that wouldn't let me ninja anything out.
I like ninja.
So, you know, we talked about flipping them a minute ago. What if I took a negative 1 out of that? Now that's going to work out. So I'm going to have negative 1, x plus 2, x minus 2. So that way that lets me ninja stuff. If I had done it like this, 2 plus x, 2 minus x, I couldn't ninja, right?
Yeah.
That's what tricks a lot of people is those signs. All right, but here we go.
Yeah, as you were making those noises, I was going to cross it out.
Alright, so on the top I've got 3x. On the bottom I got negative 1 times this. So I could write it just like that if I wanted. I might go ahead and distribute it like Katie's saying. Negative 5 minus x. Those are both correct. So you could circle either one of those you want. You know, you need to be able to adapt and do whatever a multiple choice test would have. Hey, how about this? Could you do this? Let me see here. Could I say negative 3x over 5 plus x? Yep, that's the same thing too. You could even say negative 3x over 5 plus x. That's the same thing. So be able to recognize different things that are the same, that are equivalent.
That's ABC, but I don't know what
That would be cruel.
Probably try it like at the school and like with your house.
Yeah, negative out in front just means that the whole thing is negative. So you could get that by being a positive divided by a negative, like we did here, or a negative divided by a positive, like we did there. Morning. All right, let me let you try one. You got it. I got 8k minus 16 over 3k divided by 3k minus 6 over 4k squared. All right, see what you can do with that one.
Did I get this right or did I do something wrong?
Now the case where that's we didn't do the one. Done my factoring. My factored stuff's there in red, so if you're confused, look at your factoring, see how you did. Everybody all right to the factoring part? Okay, now obvious to you are your k minus 2. Okay, so what's left on top, I've got 8 times 4 with a 32 with a k squared. On the bottom, I got 3k times 3, which is 9k. Now this one has got a new step.
You subtract.
Good. That can go farther. I'm not picking apart a binomial here. Those are monomials. So that k squared over k is just k, right? So that would be my final answer. And that's what Austin was saying earlier that Blake just reminded us of. When we divide like that, you subtract the exponents. Okay. What you think on that? Feel all right?
Are we done?
I reckon we will be. When we go to adding and subtracting tomorrow, it gets a little bit tougher because you got a common denominator.
See, you know math is bad when adding.